Good morning to everyone joining us both in person and online today. My name is Louise Butt. I'm the Business Development Manager for the South Coast Centre of Excellence in Satellite Applications. I'm delighted to be hosting the next session in the Satellite 101 series at our Space Enterprise Lab here in Portsmouth. The event has been sponsored by UK Space Agency and Satellite Applications Catapult. And today we're focusing on position, navigation and timing. I'm ably joined by Andy Gray here of Gray Consultants. Andy's team provide advisory, business development and investment services to those in the space sector. We've also got Aiden Thorne with us from Stoneline. He's a business development manager focusing on marine robotics. And Stoneline is a company focusing on the future of underwater technologies. And then online, later in the session, we've got Dave Russell from the Hexagon Group. Dave is the Marine Segment Portfolio Manager in the Autonomy and Positioning Division. Before we get started though, I just want to go through some housekeeping for those who are with us in person. We're not expecting a fire alarm today, but should you hear one, we will rush you out the door, exit you out the side of the building there and walk around to the car park, which is our muster point. For those of you who need to go to the restroom, if you come out that back door there, round by the reception, and it's just on the left-hand side. And then for those of you joining us online, keep your microphones and videos off, please, for the duration of the talks. I encourage you to put all of your questions into the chat function, and we'll cover those in the second half of the session. But without further ado, Andy, would you like to pop up?
Thank you very much. So, I'm conscious that in the room we've got a lot of PNT expertise. So I'll probably mainly talk to the camera online, because I think online we've got quite a few people who are a bit more at this kind of introductory level of PNT. So the aim of this presentation really is to sort of really just give a bit of a basis of understanding around PNT, so that it can initiate kind of conversation and discussion around what that means to different organisations and different people. So we'll go straight to the first slide, it's an introduction, and I think when it comes to PNT, what I find is it's really important to actually define what it is that we're talking about when we say PNT. So what do I mean when I'm talking about PNT? I mean any system that provides information regarding time reference, regarding a relative location, and a path between two or more locations. It doesn't necessarily have a space-based element in that. It's any system or technology that provides this information or uses this information. So what do I mean then when I talk about space-based PNT? Well, ultimately, I'm talking about any space-based technology, usually a constellation of satellites, that provides PNT information. Mostly, I'll be talking about constellations of satellites that are providing timing signals with which we derive position and location. And quite often, when we'll be talking about space-based PNT, we're referring to global navigation systems that cover the entire Earth, not quite the entire Earth, depending on when you get towards the poles, then not the same level of coverage, but roughly a kind of global coverage satellite system. Now, sometimes I might, when I talk about PNT, be talking about in-space PNT, and what I mean by that is where relative PNT information is shared between space objects or across celestial bodies, so not specifically related to the Earth. So first off, benefits of PNT. So why is PNT important? And I think it's quite divided in terms of people's understanding of PNT and the knowledge and awareness of where PNT is used in, particularly in their daily lives. So I think most people recognise telling the time. And how provision of time and information now is ubiquitous and readily available. We no longer worry so much about when we go to different countries, for example, when we cross borders, instantaneously we're aware of the change in time, all our devices are updated. You know, the clock's changed recently and it's no longer an excuse for being late to a meeting because this is automatically updated through all different systems and means that are available. Although my oven clock was not accurate because I don't have a smart oven, so that was an hour behind. Their journeys, and so people I think will be aware of using PNT technology in their journeys. That's both in terms of understanding and navigating a route, looking at the time involved in that route, potentially using this information to look at the different modes of transport that are available for certain routes and journeys, but also increasingly to track different information about our journeys and the way we travel around. So increasingly about maybe the cost, maybe the energy, the carbon footprint, all different metrics that we might gather. And also, as you've probably noticed with some of the government discussions going on at the moment, potentially taxing you as well as you travel around. Also for deliveries in terms of logistics. So by having objects that are tracked, I can be very aware of things moving around the world, coming to me, where they are at any time, potentially other information around that object and artifact. Also for finding things, finding belongings, potentially finding people. Often I find that my brother can tell where I am, and I'm not really sure how, but he's very aware of different track devices. For recording things as well. So I think time stamping is known, and now we don't really think about recording this information. It's all automatically recorded. That I take photos or videos, then on my phone, then it's known where I was, when I was, and that information is all automatically recorded and stored. And also, people may be aware of the use of PNT for their safety and security. So, thinking, maybe traveling home at night and things like this, where there are lots of apps now and devices that support us in terms of making sure we get from A to B safely and securely. And I think that most people, I think, will recognise that satellite has some form of role in that. I think that often, historically we've talked about sat-nav, and satellite has kind of been built into that thinking. I think that less people will be aware of the importance of PNT when it comes to our telecommunications network, so the operation of our mobile phones, our energy networks, the financial transactions we make when we less and less take cash out somewhere, but potentially when we use our chip and pin, or less and less that, contactless payments, and in emergency response and emergency networks as well. So here I've just touched on a few of the applications that people may be less aware of in terms of use of PNT. So PNT is actually critical. It's critical to our critical national infrastructure, to our CNI, and applications that modern society relies on a day-to-day basis. And some of those I touch on is cellular networks. So here, thinking about some of the space-based element of that, actually satellite is very important in mobile phone networks because whilst, so we need to ensure timing synchronization across the network, and whilst in the core of the network we will have local clocks and oscillators and things that will maintain time very accurately and manage that part of the system. As we increasingly go up to our nodes, we will generally be reliant on some form of satellite timing because it's very cost efficient and effective for getting that precise time across to the edges of our networks. And satellite therefore becomes a very cheap and effective way of giving almost global coverage of precision timing. Now, what does that mean? Well, actually, it means that the mobile network operators can synchronize traffic better. They can initialize and hand off calls. They can use it for accurate billing. And I think as we increase time and precision in the mobile networks, it also allows us to increase spectrum efficiency, which ultimately, what does that mean? It means faster connectivity speeds. Similarly, in energy networks, they rely heavily on synchronization. And this is particularly important at the moment as we see an increase in amounts of renewable energy introduced into the grid. Renewables generally are much more fluctuating in their supply compared to also a fluctuating demand. And therefore, it's very important that the grid is synchronized. The wind doesn't always blow, doesn't always blow at the same speed. The sun doesn't often shine. So we need to synchronize our grid to ensure that we can maintain a balance across the grid as renewables being injected. Also, if we start to think about an increased amount of local renewable energy generation, so people who are generating energy from their homes and then potentially selling excess energy into the grid. Synchronization is key, and across a wide area outside of that kind of core network, and therefore satellite becomes a great way of providing the precision time. And also for tracking. So tracking objects, tracking things around the world is key now for logistics and supply chains. People want to know where things are at any time. It still is not a perfect system, particularly when we think about shipping over long distances through maritime. And some of the challenges that actually here we're combining the telecoms element with the PNT element. So when we combine telecoms with PNT, we now have the ability to track things remotely. And it's very important for things like autonomous vehicles. So some of the background to the satellite navigation system. So actually the first system was a US system, GPS, which everyone knows and generally refers to all systems as GPS. It's the most commonly known, which is originally a military US system. The US eventually opened it up for civilian use, eventually opened it up fully in terms of capability for civilian use, for free globally, which was an enormous thing for the world actually in terms of what that provided for everyday lives. And since there's been systems provided by various countries, Russia has its system, China, and obviously heavily publicized European Union system now. But there are also regional systems as well. So these are ones that provide some form of local coverage or augmentation of PNT services. And so the US and Europe have augmentation services, which improve the accuracy and fidelity of the PNT signals over certain regions. India and Japan have regional systems. And there are also regional systems now being developed by Korea and Australia. And actually, most of the GNSS receivers that we use, they use a combination of different signals. So they will tend to not just rely on GPS, not just rely on GLONASS, but a combination. Now with Galileo-enabled receivers as well, and that can increase the resilience and the fidelity and accuracy of the information. So what has been the impact of PNT? Well, actually, now GNSS chips are prevalent. They're in multiple devices, multiple technologies. You'll probably often have more than one, if not several devices on you and around you that are have GNSS chips and have access to position timing and position information. And actually, in terms of the value of satellite navigation systems in particular, so the US estimates that since it opened up GPS to civilian applications, that it's generated 1.4 trillion in economic benefits. And in the UK, GNSS is actually estimated to support 14.7% of GDP. And interestingly, if we lost the access to GNSS for any significant period of time, so we estimate that a 5-day disruption to GPS would result in a 5.2 billion cost to the economy, which is a London Economics report. So what are the kind of general costs around GNSS and satellite navigation services? So in terms of the cost to build out the GNSS in general, for a global satellite constellation, the likes of GPS, the likes of Galileo, we're talking about billions of pounds to build this type of system to launch it. And actually hundreds of millions then per year to operate and maintain that system and for future generations. But actually the sort of further downstream costs are much less. So innovation that's been enabled by opening up these services to civilian markets mean that now you can get chips for less than £1. And actually this is supporting this widespread adoption. They're cheap, they're very small now, miniaturized, and you can put them into pretty much everything. And I think that what that has led to is more of a, why would you not include PNT space-based GNSS capability into your device, why would you, what reasons would you not rather than why you should? Because it's just so cheap and cost effective to put it in. I think that this is what we've seen with a lot of devices now. They will automatically, as standard, have some form of GNSS receiver in them. And I think that actually often it's less on the cost of the PNT system side of things in terms of when it comes to tracking, etc. And it becomes more about the communications part of the system that can be the most challenging and the most expensive when developing tracking and PNT-based solutions. It's how do we get that PNT information back rather than necessarily how do we generate it in the first place, which is done locally. And security and resilience is obviously becoming increasingly key. So as the sensors become more prevalent, as I said, as people include them more and more and embed them across different devices, different technologies, then security and resilience and ensuring the fidelity of the data can be key. And we're very, I guess, hyper aware at the moment of situations globally where people might maliciously want to affect that as well. And if we're looking at GNSS receivers that are highly secure, kind of military grade type receivers, then we're talking about a lot more cost. And that's kind of the difference, really. We get very low cost sensors that we tend to embed everywhere. And then if we actually want things that are highly secure and then encrypted, then we will be spending quite a bit more money. But there are free authentication services now that are coming online. So from Galileo, from the EU, and from the US through GPS, they're now developing services which provide additional security measures for free now to allow authentication of that signal. So what that supports is obviously resilience to potential spoofing of signals and people who may maliciously act to provide a signal that is to spoof your device into thinking that the location information is different to what it actually is. So in terms of the future, where do I see things going? And we'll have Q&A and we'll have some other expertise on the panel. So I'm happy to receive questions and thoughts around where people see the future of PNT. Some of the things I've highlighted here are just that hopefully I think we'll see a greater integration of PNT systems. So at the moment, there are various different sources of where we can get PNT information. Precision time can be provided over fiber through radio networks. We can use radio networks to locate in. We've got embedded sensors in our phone that allow us to know where we are as we navigate around. And we'll hear examples of where other sensors, inertial sensors and things allow people to know where they are in relation to a beginning point. Combined with space-based PNT, which is very useful for giving an absolute position. So hopefully we'll see a greater integration of these systems and more of a combined system of systems when it comes to people looking at how they generate PNT and use PNT information, so that we're not relying on one solution and that we're getting the best of all worlds. I think, as I say, the miniaturization and low cost, we're going to continuously see more and more things having sort of being PNT enabled and it becoming embedded in everything that we do. And this again kind of feeds into some opportunities, but also risks. And I think as a lot of people will think of when they think about sort of PNT and navigation information, increasing autonomy. A lot of people think about driverless cars and things like that, but the combination of PNT technology, artificial intelligence, and low latency networks will really allow us to achieve higher levels of autonomy in the things we do, and ranging not just from kind of driverless cars, but also into very close proximity operations of drones, vessels, autonomy in potentially in medical applications. The increase in precision will enable more and more autonomy in the things that we can have performed for us in daily lives. And I think we expect to see a greater sophistication of the algorithms. So the algorithms that feed off this information, use this information, will increasingly, I think, have a role in our daily lives that we're probably less and less aware of. and planning things for us, responding actively to us, and having sort of seamless interaction between ourselves and all the technology and devices. And there's a lot of talk now about digital twins as well, and not just digital twins of buildings, but digital twins of everything. You know, I was speaking with Max last night, who are talking about, you know, global digital twin, and people having models of everything on the earth at any time, a constant live and dynamic model. And obviously, there's a lot of applications we can think about that, where we can access this information globally at any time and manipulate things globally. And I think that whilst there's all the opportunity and all the positives, we also have to be aware that there will probably be a continued race, I think, between the security of PNT technology and the sophistication of malicious actors, which will probably continue to accelerate. And as I say, particularly I think at this time, on a global basis, we're probably hyper aware of the risks of loss of access to PNT, or a disruption, or spoofing, or malicious intervention in our PNT services. But I won't finish on that note. I'll finish on the note of I think it's important to be aware of where we're using all these devices, not just from a security perspective, but so we can leverage innovation and opportunity as well. And so I hope that this kind of brief introduction is enough for people then to start thinking about it and starting the conversations around where is PNT used in their systems, or where is there opportunities to exploit PNT to improve the way that they perform business, or the applications and services they can provide. So with that, I will finish. Thank you very much. And I will hand over to Aiden.
Thank you very much, Andy. Yes, I'm Aiden Thorne. I'm the Marine Robotics Business Development Manager for Stoneline. And yeah, I've just been asked to provide a bit of context around marine robotics and the importance of knowing where they are and when they are where they are, I suppose. Just briefly, talk about Stoneline very briefly. So Stoneline employs 370 people worldwide. We've got offices up the road in Yateley, that's our head office. I've got an office in Aberdeen, Denmark. We've got offices in Houston and Brazil and Singapore. We were set up just over 50 years ago to track divers on surveys. Now, as you can see, over those 50 plus years, technologies have moved on quite considerably in that time, and we're now looking at marine robots doing a lot of the survey work that's required at sea. So yeah, I joined Stoneline in August to look after that marine robotics part of the business. So I guess the first picture there is quite familiar to a lot of people these days, working from home. People joining us today probably from home themselves. And the thing about marine robots is you can kind of do that now. You can be an ocean-going surveyor, well, a non-ocean-going surveyor, I suppose, and use a robotic system to do a lot of your survey work. And so, you know, remote operations is a thing that's very important for us. Traditionally, when I got into this industry 20 years ago, robotic systems were deployed from a research ship and couldn't go very far from that research ship. They would be deployed over the side. Research ship would probably stay within the area of the robot, and it would come back to the surface a few hours later, and it would be taken back on board. And so your position is known by the ship. Nowadays, we've got robotic systems that are deploying the systems and doing a lot of the work on the surface themselves. So people like SeaKit and Ocean Infinity, which is down the road in Southampton, X-Ocean, are all developing surface platforms as well. There's a number of others, L3 Harris down the road here in Portsmouth, and Alton down in the southwest as well. So yeah, robotic systems are at sea, and so obviously those things are out there interacting with other shipping and infrastructure at all times. So it's really important to understand where that robot is, where that robotic system is in the water at all times. so that it will be interacting with other shipping, with pleasure craft and other infrastructure as well. So a really important part of operating a robotic system is obviously knowing where it is and how it interacts. And there's lots of regulations around that as well. So there's a group in the UK called the MAS Regulatory Working Group. They're looking at how we regulate marine robotic systems, and people like the IHO, the International Hydrographic Organization, are also looking at, and the IMO, International Maritime Organization, obviously have ultimate say on this thing. Another thing that's really important is to understand, obviously, no one's putting these things in the water because they're cool. They are, but no one's doing it just because they're cool. They're there for an operational reason. So they're out there to gather some data from a specific location, or they're out there, increasingly people are looking at using these for freight services or logistical services of other types. And so, again, knowing where the system is and when it is where it is a very important part of any of those operations. So I'm just going to go to another slide now and just talk about, because we've only got a few minutes to talk about this stuff here, just talk about two kind of operations with marine robots. And there are obviously a number of other operations that you can do with marine robots, but just two briefly here. And one is a very sort of live example for me at the moment. We currently have an X-Ocean USV, unmanned surface vehicle, out on the way to the Ormen Lange Shell site in Norway. It's 120 kilometers offshore. And what we're doing is we're going out there. Stoneline also develop long-term sort of seafloor monitoring systems. So we're going out there at the moment. There's 75 pressure monitoring systems on the floor there, and we're going out there with an X-Ocean boat. Stoneline have a transceiver on the USV, and we're going out there to basically go and suck up the data from those 75 pressure sensors on the sea floor. And obviously, we need to that boat needs to know where it is and the location of the sensors on the sea floor, so that it can successfully conduct its mission. Another example is robot-to-robot command and control and data relay. And as I said earlier, increasingly we're seeing robots that are capable of going out for weeks and months at a time now. So you don't have necessarily that mother ship, so to speak, in the loop. But what we also provide is a national navigation system that's paired with a Doppler velocity log that creates a hybrid navigator within that we can put within these subsea vehicles that you see here. And we can also put it on the surface vehicles as well. But that navigator is acoustically powered, and it needs to know where it is before it can get going. So you can give it a false position. You can just say you are here, and it will know then that it's navigating, or you can give it a real position. And that's done obviously by initially talking to a satellite system, giving it a position. But obviously, as it's down underwater in a GNSS or GPS denied environment, it will drift over time. And our sensors are very accurate, but over time, you're going to drift by 0.05 or 0.01, depending on what sensor you put inside. And of course, that doesn't sound like a lot. If you're down for a very long time and you're on a long mission, that's going to add up to a good number of meters over a long period of time. So what we do to make things more reliable nowadays is Stoneline also have systems that will enable us to communicate between the subsea vessel and the surface vessel, and we can then get a position update from the surface vessel that can keep updating the subsea vessel. This means that when we're gathering that data subsea, we're getting reliable data fed into the robots, and we can also now feed that back up in real time, back to that satellite, back to that guy that's working from home, maybe, or in a remote space somewhere, so that you can QC that data live, and then if something's wrong with it, we can do another fly past and understand where we are. So yeah, it's just a brief introduction to why it's important to understand where and when a robot is where it is. I think I've got to hand back over to Lou now.
That's great, Aiden. Thank you very much. Really appreciate your talk, and yours as well, Andy. We're now going to be joined by Dave Russell from Hexagon. He's joining us remotely, so we will just get him to share his screen now. Dave, if you could do that, please.
I've shared my screen. Hopefully you can see it.
Yes, we can, thanks.
Okay, just following on from the previous two presentations, my name's Dave Russell. I'm Marine Segment Portfolio Manager at Hexagon. I've been in marine business well over 20 years, mainly working in satellite navigation. And Hexagon is a positioning or a measurement company, and the division I work for is autonomy and positioning. Just to give you a bit of an idea of what's in that division, we have Novotel, who are a GNSS manufacturer, who build OEM products that can be integrated into third-party systems. So if you've come across Leica, they're using Novotel hardware in their boxes. Antcom is another facet of our organization that manufactures antennas for positioning and also for communications, whether that be satellite communications or subsea communications as well. And Veripos is the division I started with. We were acquired in 2014. Veripos has been active in the oil and gas market since '89, providing corrections through terrestrial HF networks and subsequently moving into satellite positioning and providing what we call precise point positioning, delivering global high accuracy positioning solutions to the oil and gas market. And then the two other divisions that have kind of joined the family since is GPS Solutions, who are a company based out in Boulder in Colorado, who are a company that basically does software development of analysis software and also develops all our orbit and clock solutions that we use for our PPP service. And then finally, Autonomous Stuff is a company we acquired who are developing a lot of autonomy solutions for, initially it was for automotive, but we've now moved more into the off-road autonomy market. So whether that be agricultural, defence or marine, that's the area where we see our speciality being able to be exploited. In terms of the problems that we solve, it's all about assured positioning. I think when I first started in the industry, we were very much providing a terrestrial solution that had limited reach and range. When GPS came along, that gave us the global coverage that we kind of wanted to allow exploration further into offshore oil and gas markets. And then subsequently, the push has always been then to push the accuracy that we can deliver. So we can now provide real-time positioning down to the centimeter level anywhere in the world, provided you've got an appropriate communications link. And the next kind of phase that we've moved into a lot of is understanding the vulnerabilities in GNSS and being able to protect that. So again, through other sort of vertical markets within our organization, such as the defense guys, we've developed a lot of anti-jam, anti-spoof capabilities to help protect GNSS solutions. We're also working on integration with multiple sensors. So again, as Aiden pointed out, that a lot of these autonomous vessels will have an inertial platform on the vessel itself, and we're keen to hook into that to be able to do a deeply coupled integrated solution. Through the autonomy side of things, we're doing a lot of work on the perception side of things, whether that's through vision, through LiDAR, through radar. But we're also not just doing it from a perception capability point of view, but also using that information, the positioning side, to provide a more robust solution where we're not completely reliant on the GNSS solution. So in terms of fundamentally what we provide is we provide the hardware, the GNSS receivers, the antennas, the correction services, the entire solution that can be put onto a vessel to deliver that high accuracy positioning. And the key part that we've been working on is Veripos over the number of years is the correction services. So this slide kind of highlights the main components with respect to the core technologies that we have to deliver that. So obviously the fundamental thing that we use is the GNSS constellations. We have always kept an eye on how they've evolved and how they've varied, and the capabilities that have come through the modernization of all the constellations. It is something now that allows us to deliver precise positioning and fast convergence PPP solutions. We basically have a tracking network of between 80 and 100 stations around the world that are real-time tracking the data and transferring it to our control centers in Aberdeen and Singapore. And then from that, we basically also take in some regional networks for basically higher accuracy, faster convergence stuff. That's mainly in North America, in the agricultural belt. That all feeds into our control centers, from which we then generate real-time corrections that we then deliver to uplink stations for broadcast through mainly the Inmarsat L-band communications satellites. And the reason why we use that is the footprint that they give us is quite wide. So, 5-7 satellites gives us global coverage with redundancy. Our main issue is when you go up into the polar regions, but again, we provide our data through secure internet delivery, so that can be also delivered through other platforms such as Iridium. And then ultimately we provide the receivers and the algorithms on those receivers to receive all that data and then basically compute a position. And that's what we've been that's been our bread and butter, if you like, for the last number of years. But again, pushing things forward, we've kind of reached the accuracy values that we can't push that much further. But for certain markets, again, we're being asked to provide assured positioning. So again, improving the anti-jam, anti-spoof capabilities. In certain other markets, we're also been asked to provide what they call safety critical solutions. So again, certifying our network, certifying the corrections, certifying the protection levels that we can deliver as part of that service. It is a key aspect, and I think ultimately that will also feed through into the marine environment as well. And then finally, just some, so again, we provide a lot of position for oil and gas, nearshore survey, that kind of thing. And I guess there's a lot of talk about unmanned autonomous platforms. Again, we're heavily involved in those areas as well. So again, our Veripos is equipment on the Mayflower autonomous vessel, which is hopefully sailing this April from the UK to the US to recreate the original Mayflower voyage. We're also involved with other partners through Novotel, integrating our GNSS cards into AUVs. So we got the Kongsberg Hugin and the Remus system as well use our cards. The Remus also uses our antennas from Antcom, and then the Yara Birkelands and Sail Drone are other examples of where our technology is being used to help deliver surface positioning. So again, we don't deal with the subsurface position. I guess that's where companies like Sonardyne have the expertise. We provide the surface level positioning, and again, being able to provide that sort of geographical reference that allows you to come back multiple times to the same spot is the benefits of the GNSS platform. So that's the kind of areas that we're involved in, and basically unmanned autonomous platforms. And again, we see that as a massive growth area, and something that we're continuing to support and work with strategic partners to deliver the solutions. And then so that's me. That's a quick overview of Hexagon and the autonomy position division and what we do in the marine business.
That's great, Dave. Thank you very much. If you want to stop sharing your screen, and we'll move to Q&A. So let's see what we've got in the chat here. Right, first on the list, do PNT applications need to be space-based? how about a system of systems approach that includes terrestrial elements?
So actually, I'll take the opportunity to introduce Andy Proct, who lots of people who work particularly in the space world, but across PNT will know. And it's probably a good question pretty much. So I'll straight off introduce Andy to answer that, and that's all right.
So thanks for the question, whoever asked it. It's really important, I think, in a holistic PNT environment to use terrestrial-based technologies. Space is great, and it's always going to be the first sensor type you go to when you have a PNT system, unless you're on the water, of course, because it's really cost-effective and simple technically to integrate. But it's not the whole answer. So when you talk about terrestrial systems, you could consider it inertial navigation or radio navigation systems. Optical navigation systems, even human navigation systems for electromyography. They're all part of the solution, and if you're going to create an always available position or time, if it's going to be resilient to problems and issues, then you need to create that system of systems environment where you're using lots of technologies.
Okay. Yeah, of course.
Yeah, I mean, as I mentioned earlier, we create national navigation systems, and we've got acoustic tracking and optical tracking systems as well. And yeah, they're all part of, as Andy just said, a system of systems. But you obviously need to start from a reference point. So you need to know where you are to start with. And so yeah, having that kind of satellite interaction in the first place is very important to those systems. As I said earlier, you can give it a false position if you want to just contain yourself in an area because you know where you are. If you're doing over the horizon operations, where you're not really in contact with that vehicle in line of sight, then yeah, you do need to have that satellite part of it as well.
Right, fantastic. I had a question. There was lots of talk around security. So is this something we should be worried about in terms of PNT? I don't know who wants to take that one.
I mean, I can simply say yes. I mean, yeah, it's not that if we lost access to one of these systems, that instantaneously the world would fall apart, and our world would fall apart. But we are increasingly reliant on them, and we need to be thinking about the impacts of security and the breaches of security on those systems. And it was raised at Space Command by MOD as being a key topic and concern for them. And I know that Andy's been discussing this a lot with government over the last few years as well.
Yeah.
Sorry, can I just add to that? I think it goes back to Andy's first point as well. I think protecting PNT, I think every PNT solution has its own vulnerabilities, and understanding what those vulnerabilities are is essential to actually making a more robust solution. And I think it doesn't rely on one single system. It relies on an integration of different sensors and different technologies to actually deliver that. And I think that's one of the key things that we see. Certainly in marine, there's always been the case that, we've advocated that, we have multiple systems, but in dynamic positioning, we've relied on relative positioning through lasers or microwave systems as a backup or an alternative solution to positioning. And I think that's a key thing that we have to always remember, that there is vulnerabilities in what we have, and we need to make sure that we're trying to address them as best we can.
Okay. Oh, a question from the crowd.
So Simon Atkinson from Rogue. I've got a related question to the discussion just now, probably specifically for Dave, to ask, with your applications and your customers, are you seeing increasing levels of interference or spoofing on your GNSS systems, and particularly, for example, now in the Black Sea with what's going on there?
So I can answer that. So we've actually had big issues with interference and jamming, particularly in the Eastern Mediterranean, probably over the last number of years. And that's been predominantly because of the Syrian conflict. And then typically we usually find we have problems with interference or issues with GNSS when any military vessels are within operating range of your vessel, because they're obviously jamming things. We've not got many customers working out in the Black Sea at the moment, but we do have one customer who is about to mobilize vessels out to a project offshore Turkey, and they're actually looking at buying some anti-jam antennas to help mitigate against that. So it's something that we're aware of. I guess offshore it's more difficult to jam than it is onshore because of just the geographic size and the differences. But we're certainly starting to see more and more instances of jamming and basically issues, particularly not just with our systems, but with AIS systems moving closer to shore when they're starting to transit through, say, the Suez Canal or things like that. We've had certain reports of that as well.
Can I make a comment? So I agree with everything that's been said so far, but there's one point that hasn't been brought out to date, and it's about when you have your PNT information, what do you do with it? And I think increasingly we need to be considering how we secure that. So without taking anything away from the jamming and spoofing and the installing antennas incorrectly causing problems, we also have to think about how we secure what we do within applications. Because, for example, in your application, if somebody was to hack into your PNT data, it would be fairly catastrophic. So I think as well as protecting at the physical layer, we also need to protect the data layer.
Just add to that as well. So obviously we have these international navigation systems that we've built and put onto the system. And the nice thing about that is, we integrate with lots of Dave's company to ensure that we're getting regular GNSS feeds into those. But if suddenly we see something that's jammed or it's spoofed, we can see instantly, well, we weren't there a moment ago, so in that INS system, so it will effectively reject spoofed data that's been sent through, and you've got that onboard redundancy in that system that enables you to continue to navigate until such time as you're getting a genuine feed again, and then you've been able to bring that back in and understand that understand where you are again.
Okay, well, this is a question that was submitted earlier. It's probably for Andy. How is Brexit affecting the UK's interaction with the EU PNT programs?
As well. I don't know. I don't know anyone that he's well aware of, and was very much part in these discussions, I think. But there's been a lot of discussion across the board about satellite programs in the UK as a result of exit from the EU. Obviously, not the ESA programs, which are separate, but the ones that are ultimately funded by the EU, such as Copernicus, the Earth observation program, and obviously Galileo. There's a lot of media around that at the time. A lot of discussion, a lot of negotiation. Ultimately, we're not part of the Galileo program anymore, and obviously we have investigated what the UK does in the absence of that, and it's not determined yet. There still remains a lot of knowledge and capability and technical skills in PNT and particularly GNSS in the UK, and I think that. It will. At the moment, it's not clear actually what the impact will be, because I don't think we have a very clear direction and solution yet as to how we maintain, if we choose to maintain that capability.
Any other thoughts from the panel before we move on?
I suppose I ought to say something, considering I was on the Galileo program. Working for the Space Agency, rather than the program itself. It is correct to say we're no longer part of Galileo, and it is also correct to say that our industrial return has gone away. But the UK was really fundamental in Galileo, so it's important to recognise the achievements of the UK there. Where we've come out of Galileo, it's really key to understand that it doesn't mean we can't use Galileo. Galileo has got open services and commercial services that you can pay to use. So it's not the case that we can't use it. We can't use the secure elements of Galileo because we're not part of the program and we're not EU members. That's more important for those that need that sort of encryption and security. And Andy's right to say that there's still not a solution for that problem. Where there are other aspects that were perhaps not really publicised is coming out of the EU, we're also out of the EGNOS programme. The UK took a decision not to remain part of that programme, and that impacts not only on smaller airfields and the ability to determine landing decision heights, but also EGNOS as a programme, which has got a great future ahead of it, was really looking to make a big difference to the maritime environment. And it was doing this by providing a lot of near integrity services coming on stream, specifically for the mariners. We won't have access to some of those services, so the UK is actually actively looking at whether we can replace some of those services in collaboration with the EU. It's announced that there is a European Space Agency project looking at what a UKSA could look like, and there's a test bed being developed at the moment. And the idea is that we would try to replace some of the capability we lost. So there is work going on. It's not as much as we would have otherwise had staying in those programs, but at least it's not completely dead.
Okay, fantastic. Just looking at the chat, there's another question here from Phil Buckley saying, I'm wondering if we should be separating T from PNT.
So I think when it comes to applications, we might want to discuss them separately because maybe it gets confusing sometimes whether we're talking about something that is just about precision timing or whether it's about position navigation as well. But in terms of the solutions, I mean, they sit together. I mean, that's why it tends to be PNT, because you always need some kind of precision timing element to have the position and navigation information. Really, I think with whatever technology you use, you still need some kind of timing. It doesn't necessarily have to be an external source, but some form of timing information, whether that is the timing signals from space that we use to derive our location, or whether with other solutions like interferometry that people use for locating things as well, or for time stamping maneuvers and inertial measurements. There is always a PNT in the solution side, if not necessarily the application side, unless I've missed a solution that doesn't need timing.
Just to come in on that, we find in a lot of marine vessels that there's a lot of GNSS or GPS systems installed on vessels because they do provide a time solution, but they're not actually used for any of the position or navigation. They're just purely used for a time source. And they actually can be one of the sources of interference that we get in our GNSS systems because of badly earthed antennas and that kind of thing. But we've certainly found over the last sort of 15 years a sort of plethora of systems appear on vessels to basically have GPS provide a time source for whether it's an engine management system or anything like that you would never even think would be using a satellite positioning system in its operation.
Okay. Dave, if I can target you with this question, are you seeing any kind of particular new emerging technologies or innovations in kind of when you're looking at the PNT market and providing solutions in that space?
So the main things that we're looking at, obviously there's the modernization of the GNSS platforms, the addition of more signals and frequencies. That's the key thing that we want to exploit. Beyond that, communications channels is a big thing for us because, again, one of the things that's maybe overlooked a lot in remote unmanned operations is actually having good data communications with these vessels. and having high bandwidth availability, that kind of thing, and also robust, reliable, and secure communications. So that's an area that we are actively looking at and looking to see how we can utilize the backhaul of data from vessels to augment what we do, whether that's through real-time jamming detection, information, that kind of thing. And then the other thing is the addition of other sensors on vessels and how we can actually utilize that to basically improve the robustness of our GNSS solution. That's an area that we're looking at across not just marine, but other markets as well.
Okay, thank you. So I'll ask the same question to both our roundies, but without thinking about the marine environment. Are you starting to see kind of new technologies coming online for PNT for other sectors?
Well, actually, I'll do a non-space plug, which is we do have a national timing centre now that's funded by government, which is all about delivery of precision time and different ways of doing that, and that supports multiple sectors as well. So they've got innovation programs to develop new technologies on how you can disseminate precise time, increasingly precise time. And then I'd say the other things that are kind of connected and linked in is also the quantum side of things. I won't go into the quantum side because it's not my expertise, but the application, my understanding is that the technologies that can be developed off the back of quantum capabilities will also be able to impact on what we're able to do in terms of precision of timing, but also security as well.
So, yes, I was going to talk about the quantum stuff, but I won't. Clocks will be the really important aspect of the future, but I think in the near term, because quantum is always 10 years away, in the near term, I think software integration of different sensors and decision-making algorithms about which PNT source that we trust, I think those are going to be really important in the next few years, because people will be developing systems of systems. So which of those systems do you trust at any particular time? I think that sort of intelligence in the software is going to be quite important.
Yeah.
Just think about net zero, and there's a huge discussion around, obviously around fuels and everything, which tends to almost throw up barriers because of timescales involved and difficulties in storage and so on. To what extent is your community talking about, obviously, just doing things better, just smaller, but doing things on time, sequencing, logistics, and so on? Is there any sense of how much closer you get to net zero through just doing things better through this technology, rather than having to move completely to hydrogen or something like that?
So coincidentally, I've just been doing some work on transport sector, and it's around about 29% of transport emissions, greenhouse gas emissions, are from aspects where you can reduce that through PNT. But better knowledge of location and being able to have location more accurate, more available, and more trustable, you can make better decisions, and then you can reduce, just simply through operational efficiencies, you can reduce that the greenhouse gases, the emissions. And whilst I'm not going to say it will solve the net zero problem, what it will do is support activities that will get towards that. So, and that's something we can do today. There's a lot of technologies exist today that if we implement, we can make a big difference.
Okay, so I'm looking at the time. We've probably got time for one more question. So earlier we had a question around, are there different types of satellite navigation systems or just different operators?
Well, yeah, so there are different satellite systems. There are very similar systems, and there are very different systems, particularly that are being proposed at the moment. So, you know, obviously the traditional delivery model for time and signals from space is medium Earth orbit constellations of 20-odd satellites. Increasingly now, there's people looking at and developing solutions using different technologies in sort of low Earth orbits, potentially leveraging existing signals that aren't specifically timing signals, that are communication signals that are driving position as well. And I know that, again, Andy saw a lot of papers on different proposals for different technologies for space. So I don't know if there's any.
So the answer is yes, there's a lot of opportunity for different types of PNT systems in space. The MEA system that Andy mentioned, they're generally governmental operated, US, Chinese, Russians, Europeans, etc. But it is possible to have some aspects of PNT from commercial geostationary satellites. There are proposals from UK companies and from US companies and Chinese companies for doing low Earth orbit PNT, as Andy said. Some of these are independent, so they'll be completely separate. Some of them provide what we call rebroadcasting technology. So you gain a degree of resilience, but it's not wholly resilient. And within that, you have people looking at just using the fact that satellites move through Doppler positioning, or using communication systems in an opportunistic way, or in a very similar way to the current GNSS. So there's a lot of innovation happening. I don't think the future will be similar to as it is today. I think there's going to be a lot of change over the next 10 or 15 years.
Okay, and on that note, we shall wrap up. Thank you to everybody who attended today. Thank you to all our speakers, Andy Gray, Aiden Thorne, Andy Proctor, and you there online with us, Dave Russell. Thank you everybody online. Have a good day. Goodbye.
Thank you.